For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@matlabassignmentexperts.com, info@matlabassignmentexperts.com, or reach us at https://www.matlabassignmentexperts.com. P.1 Consider the two feedback systems in figures P25.1-1 and P25.1-2. A. Express the overall system functions in terms of the system functions in the forward and feedback paths. For the remainder of the problem, assume that Ks and Kz are both constant values k and that. Problems. MATLABassignmentexperts.com. B. Plot the pole zero pattern of Qs and Qz for k equals 0, -1, and 1. C. Indicate the locus in the S-plane of the poles of Qs and in the Z-plane the poles of Qz, as k increases from k equals 0 toward large positive values and as k decreases from k equals 0 toward large negative values. D. Specify the range of values of k for which each of the systems is stable. P.2. For the systems in figures P25.2-1 to P25.2-3, derive the transfer functions indicated. MATLABassignmentexperts.com. MATLABassignmentexperts.com. P.3 Consider the system GS with frequency response G, JW, indicated in figure P25.3-1. A. Sketch the approximate overall frequency response of each of the feedback systems in figure P25.3-2. MATLABassignmentexperts.com. B. Determine which of the two systems in part A attempts to equalize the gain G, JW, i.e., to make it more constant over all frequencies, and which system is intended as an approximation to a system that is the inverse of G, JW. P.4 Consider the basic feedback systems of figure P25.4. Determine the closed-loop system impulse response for each of the following specifications of the system functions in the forward and feedback paths. MATLABassignmentexperts.com. MATLABassignmentexperts.com. P.5 For the system given in figure P25.5, find Ys in terms of Xs and Ws. P.6 Consider the causal discrete time system depicted in figure P25.6. MATLABassignmentexperts.com. A. Show that this is not a stable system. B. Suppose that we allow feedback with 1 unit of delay. That is, suppose that xn equals xz n chi n minus 1, where xe n is an externally applied signal now regarded as the input to the overall closed-loop system. Is it possible to stabilize the system with feedback of this form? If so, find the maximum range of values of k for which the system is stable. C. Suppose that instead of using feedback with 1 unit of delay as in part B, we allow feedback with 2 units of delay, so that xn equals xn chi n minus 21. Specify the full range of values of k, if any such values exist, for which this system is stable. P.7 In this problem we illustrate how feedback can be used to increase the bandwidth of an amplifier. Consider an amplifier whose gain falls off at high frequencies. Specifically, suppose that the system function of this amplifier is MATLABassignmentexperts.com. A. What is the DC gain of the amplifier, i.e., the magnitude of its frequency response to zero frequency. B. What is the system time constant? C. Suppose that we define bandwidth as the frequency at which the magnitude of the amplifier frequency response is 1/2 times its magnitude of DC. What is the bandwidth of this amplifier? D. Suppose that we place this amplifier in a feedback loop as depicted in figure P25.7. What is the DC gain of the closed loop system? What are the time constant and bandwidth of the closed loop system? E. Find the value of K that leads to a closed loop bandwidth that is exactly double the bandwidth of the open loop amplifier. What are the corresponding closed loop system time constant and DC gain? Matlab assignmentexperts.com. Solutions S.1 A. We have versus equals XSY, S, K, S, and YS equals V, S, H, S from EQ, S25.1-2, substituting EQ, S25.1-3, into EQ, S25.1-1, we have Matlab assignmentexperts.com. Similarly, B. As shown in figures S25.1-2 and S25.1-3, respectively. Matlab assignmentexperts.com. For K equals -1. As shown in figures S25.1-4 and S25.1-5, respectively. Matlab assignmentexperts.com. For K equals 1. As shown in figures S25.1-6 and S25.1-7, respectively. The pole is located at S equals 2, 1K, as shown in figure S25.1-8. Matlab assignmentexperts.com. Hence, the locus of the pole is the line re, S equals 0. Similarly, 4. The locus of the pole is also the line re, Z equals 0, shown in figure S25.1-9. Matlab assignmentexperts.com. The root location decreases as K moves to infinity and increases as K moves to negative infinity. D. The system is stable for 2, 1K, 0, or K1. The system is stable 4-12, 1K, 1, or K less than I. S.2 we use problem P25.1. A. Matlab assignmentexperts.com. Matlab assignmentexperts.com. S.3 A. Matlab assignmentexperts.com. B. From the frequency response in part A, clearly System 1 tends to make the response more constant and System 2 tends to resemble the inverse of G, JW. S.4 For the system in figure S25.4-1, we denote the closed-loop system function by Matlab assignmentexperts.com. Therefore, V, T equals TE22, T. In this case, V, T equals Lu minus 22, T, C. The system function GS equals E113 corresponds to a delay of 1, i.e., the feedback system of figure P25.4, A, becomes that shown in figure S25.4-2. Matlab assignmentexperts.com. We can now recursively obtain the impulse response by inspection. With xt equals 8t. Therefore, Matlab assignmentexperts.com. S.5y t equals K2w t plus KK2v t. By taking the transform of EQ, S